Welcome. We are excited to share this video that will introduce the document titled Methods to Check Dimensional Tolerances on Hollow Structural Sections. This document, also termed the Tolerance Brochure, was developed by the Steel Tube Institute and its member HSS producers. It serves as a guide for those within the HSS steel supply chain, including HSS producers, steel fabricators, and service centers, to take dimensional tolerance measurements for HSS and ensure steel tubing falls within ASTM permissible tolerances. This document can also assist designers, engineers, and architects to understand what the tolerances are as allowed by ASTM A500, which is good to be aware of for detailing steel. The STI tolerance document has also been approved as a standard guide for measuring HSS tolerances per ASTM's A500, A847, and A1110. The STI tolerance document can be found on the STI website at steeltubeinstitute.org/tolerances. We hope you find these videos helpful. Today, we will demonstrate how to take these measurements shown on this list: outside dimensions, wall thickness, length, straightness, squareness of sides, and corner radius. Due to the infrequency of twist-related issues, there will be no video demonstrating how to check for twist tolerance. In each video, you will see on the left-hand side a list of tools needed for each measurement, the main steps to perform the measurement as outlined in the STI tolerance document, and the ASTM A500 permissible tolerances listed. Common to all measurements, it is best to remove as much burr as possible from both ends of HSS sections prior to taking measurements. We also avoid taking any measurements at the weld seams of the HSS. We will start by summarizing the tools needed to perform HSS tolerance measurements. In this video, you will see the measurement tools listed on the left and the video showing a sample of these tools displayed to the right. We see radius gauges, micrometers of different sizes, protractors, tape measure, straight edge and ruler, among other tools as listed on the left. This video will demonstrate how to take the outside dimension measurement for an HSS sample. We have a square HSS 3.5 by 3.5 by 1/4 and are using a 3-inch to 4-inch outside micrometer. The OD measurement will be taken at 6 points across the flats. We want to ensure that we take the OD measurements a minimum of 2 inches from the ends of the HSS. Our first measurement is near the start of the outside corner radius along line A. The OD measurement at this point is plus 0.011 inches above the specified outside dimension. The second measurement is near the center of the flat along line B. This measures at minus 0.010 inches below the specified dimension. The next measurement at the corner radius along line C measures at minus 0.003 inches. Table 3, shown on the left from ASTM A500, shows the permissible variation allowed for our HSS 3.5 by 3.5 section is plus or minus 0.025 inches, which we have met so far. Fourth dimension, line D, at the corner radius measures at plus 0.010 inches. The next measurement near the center of the flat is along line E. This measures at plus 0.002 inches. The table on the left shows the ASTM A500 permissible variations for the small flat dimension. In our case, the outside dimension can vary up to a tolerance of plus or minus 0.025 inches. Now our last measurement near the final corner radii measures at plus 0.001 inch. Here is a summary of all measurements in thousandths of an inch. Since all measurements are less than 25 thousandths of an inch, the outside dimensions of this square HSS is within tolerance. If we had a round HSS sample, we would take that measurements at 3 points around the tube. For the same HSS 3.5 by 3.5 by 1/4 section, we take one wall thickness measurement away from the weld seam. For square or rectangular HSS, we measure near the center of the flats. We will use a 0-inch to 1-inch ball micrometer. You can see this section does have some burr at the ends. The micrometer needs to be large enough to measure the HSS behind the burr. We have a gauge or thickness reading of 0.249 inches. For a 1/4 inch specified wall thickness, that falls within the 10% acceptable range permitted by ASTM A500. This video will demonstrate the length measurement. For the round HSS bundle that you will see, we want to make sure the ends of HSS have minimal burrs. All we will need for this measurement is tape measure. We can go ahead and pull our tape tight to measure the overall length. We will see that our final measurement is a little over 42 feet. Therefore, we have an HSS bundle that is greater than 22 feet. Looking at the ASTM A500 length tolerance table on the left, we need to confirm that the final length measurement falls either plus 3/4 of an inch or minus 1/4 of an inch from the specified length for this piece. This straightness measurement is a tolerance unique to HSS sections. We will perform a string line test to measure for straightness on this round HSS bundle. Here we have a 20-foot long bundle and we have removed burrs from both ends. We've attached a string line to each end of the bundle and pull the string tight. We approach the largest bend or deviation from the string line and measure the distance between our string line and the face of the HSS. We measure 1/8 inch. Per ASTM A500 equation shown on the left, the permitted variation over 20 feet is 1/2 inch, which is greater than the 1/8 inch measured. Straightness for this HSS is found to fall within tolerance. Next, we will measure squareness of sides for our HSS 4x4 by 1/4 sample. We will need a protractor to take this squareness measurement. We will place the protractor on one surface, then adjust the protractor to measure variation from 90 degrees at each corner. For the first corner, we read an angle of 89.9 degrees. We proceed to check the remaining 3 corners to measure squareness. The second corner measurement is 90.3 degrees. ASTM A500 section 11.5 permits this measurement to vary within plus or minus 2.0 degrees from 90 degrees. The third corner measures at 90 degrees. And the fourth and last corner is also 90 degrees. Therefore, we find that the squareness of sides for this HSS sample is acceptable. Our last demonstration will be the corner radius measurement using method 2 in the STI tolerance document. We will use a ruler and a straight edge. For the same HSS 4x4 by 1/4 section, we place the ruler on one side of the corner, shown here on the right, and the straight edge on the other, shown here on the bottom. The key is to determine where the corner starts. Imagine the corner as part of a circle and draw a tangent line parallel to the face of HSS. The blue line is our tangent line. Start the measurement at the intersection between that blue tangent line and the start of the corner. Then measure the distance to the straight edge. The first corner reads 16/32, which is equal to 1/2 inch. For a 1/4 inch wall thickness, a 1/2 inch radius is equal to 2t. 2t is less than the ASTM permissible 3t, so that first corner is acceptable. Now we need to walk through and check all remaining 3 corner radii. We find the second corner radius is the same as the first corner, resulting in 16/32 or 1/2 inch, which is also equal to 2t and is acceptable. This third corner also results in 1/2 inch radius. Finally, the fourth corner also results in 1/2 inch radius, which is equivalent to 2t. 2t is less than ASTM A500 permissible 3t. So all 4 corner radii fall within acceptable tolerances per ASTM A500. This concludes our HSS tolerance video demonstrations. We hope this video was a helpful guide in taking tolerance measurements for HSS. For more detailed guidance of the STI tolerance document, you can view a complimentary recording of STI's webinar titled Measuring HSS Tolerances. This recording can be found on the STI website at steeltubeinstitute.org/tolerances. Thank you to the Steel Tube Institute's HSS member producers who worked to develop the STI tolerance document. Special thanks to Searing Industries and Atlas Tube for their helpful video contributions. Feel free to contact us to ask any questions you may have. Thank you for your time.